on page 14. And we always start with an x by x box. On one side, it does not matter which side, you're going to add 3. And on the other side, you're going to add this 5. So if you look inside, this box is an x squared. Because this is x, this is also x. It's the same length. So this box in green is a 3 by x. Because this is 3, this is also 3. Same side of the rectangle. So the red box up here is, well, this is 5 and this is also 5. So we have 15. And then the other red box would be 5x. So if you look at the colored things inside, they match up with double distribution because x times x is x squared. And then x times 5 is 5x, same as that. And then 3 times x is that 3x. And 3 times 5 is that 15. You must put your like terms together to get the proper form. X's can be added, so we have x squared plus 8x plus 15. This is our expanded form. We were given quadratic form. On a little side note, and go ahead and write this somewhere on your sheet, x plus x is 2x. X squared plus x squared is 2x squared. X squared plus x is just x squared plus x. You can only add and subtract like terms. When it comes to multiplying, you can multiply anything. So x times x is x squared. X squared times x squared is x to the 4th. And x times x squared is x cubed. So multiplying, you can do anything. Exponents change. Adding and subtracting, you can only add like terms. So if you have like ABC plus AB, that's just ABC plus AB. You have to have an ABC to add to an ABC. So if we look at our second number 2 equation, addition is commutative. I'm going to rewrite this in the proper form with the letter first. And then if you think about your box, your initial x by x, we're going to add 4 to one side as well as the other. So x times x is x squared, and that's right there. X times 4 is 4x, and 4 times x is also 4x. And then 4 times 4 is 16. You do need to put the like terms together, so we have x squared plus 8x plus 16. That's our expanded form. This last one's a little bit different because of the 3x out front. So we're going to start with our x by x. The 3x means you need 3 x's. If you remember from what I just showed you with adding and subtracting, x plus x plus x is 3x. So we would have to add 2 x's to get one dimension to be 3x. And then the other dimension, we're going to add 1 to. But we do need to add it all the way across. So if we distribute this out, we get 3x squared, and that's because we have 3 x squareds. X squared plus x squared plus x squared is 3x squared. And then these boxes are each x because they're each a 1 by x. All of these are x's. So x plus x plus x is 3x. So So that multiplication is 3x. The next one says Carminda said she doesn't want to draw a rectangle, which is fine, that she's going to do her method this way. So she has this x plus 3 written here and here, and this x is right there, and this 2 is right here. So what she has done is she has distributed the x through to get that, and then she distributed the 2 through to get this, and then she put her like terms together. So Carminda did a good job. She distributed. And she is correct. Typically, we distribute the first parentheses out. There's also something called the FOIL method. I just like to think of it as double distribution. But this stands for first, and these are your first terms. I'll color code this. Outer, and these are your outer 2 terms. Inner, and these are your inner 2 terms. And last, these are your last 2 terms. Regardless, you're going to get the exact same answer, and that's what foiling is, which is double distribution. We're going to skip number 2 because I actually just did it above. So we're not going to necessarily draw a box right now, and we're just going to distribute. X squared plus 5x plus 5x plus 25. Why don't you go ahead and pause right now and try the next one, and you can do this for each of them and see if you're getting the right answer on your own. I'll keep going. If you're losing your negative, you might want to make that plus a negative to make sure you have your negatives. Add your like terms. Again, go ahead and pause and do number 3. Remember, 2 negatives multiply to give you a positive. And this last one's something special. It's called difference of squares because one's a plus and one's a minus, and the stuff in the parentheses is the same. And in the difference of squares, the middle 2 terms cancel each other out, and that always happens. All right, so now we're flipping over to page 15. In page 15, we are going to be figuring out different possibilities that this could be. So numbers that multiply to give you 9 are 1 and 9. So this could be a 9x, because that would be a 9. And this could be a 1x. So we could have x plus 1 times x plus 9, and that would give us x squared plus 10x plus 9. Option number 1. Option number 2. Any other numbers that multiply to give you 9? Yes. 3 and 3. So this could be x plus 3 times x plus 3, which is x squared plus 6x, because there's 2 3x's, plus 9. So if our last term is 9, our middle term could either be 10 or 6, and that would be factorable. So the next question is the same thing. It's saying, what is the middle term if the last term is 8 to make this factorable? So I'm going to think about my box here. And since this is an x squared, I know both of those are x's. For my 8, I need to figure out what two numbers multiply to give 8. And I'm going to actually color code this. This side length is the same as this side length. So one option would be to make this 1 and 8, or 8 and 1, doesn't matter. If that's the case, this would be 8x, and this would be 1x. So we would have x plus 1 times x plus 8, and that would be x squared plus 8x plus 1x, so that's 9x plus 8. But there's another option. Since I'm not here, we're just going to draw the other one. So again, these are both x's. And what two numbers multiply to give you 8 besides 8 and 1? And that is 2 and 4. So it doesn't matter which is the 2 and which is the 4. You'll end up with the same exact thing. Again, since that's x, this is x. And since this side's x, this side's x. So these boxes are 4x and 2x. So my outer dimensions are x plus 4 and x plus 2. And it doesn't matter if these sides are flipped. You still have x plus 2 and x plus 4. And the inner dimensions are x squared plus 4x plus 2x plus 8. You need to put your like terms together. So x squared plus 6x plus 8. Alright, so we're going to find what r would be. And we already know that one of our dimensions is 6. So think about your box again. This has to be x squared. That always goes there, which means these are both x. The 24 always goes right here. So now we need to figure out what two numbers multiply to give 24. And we know that one of the dimensions is already given as 6 because 24 has a lot of different multiples. 1 and 24, 2 and 12, 3 and 8, and 4 and 6. 6 is already one of them. Doesn't matter if it's in the blue or the red. This now tells me that this is 6x. So since the one is 6, this would have to be 4 because 6 times 4 is what gives 24, which means this box is 4x. So this factors into x plus 6, which we already have, x plus 4. Our r value is 4. In the next one, we don't have either of the dimensions. So we're going to look at our box again. You got to love these boxes. So this is our x's, our x squared. This is still our 24. And I want them to add to give me 11. So I'm going to look up here at my factors. 1 plus 24 is 25. So that does not add to give me 11. 12 plus 2 is 14. That does not add to give me 11 either. 8 plus 3 is 11. This is so exciting because this now is the 8 and this now is the 3. Or they could be flipped. But one of these boxes is a 3x and one of them is an 8x. So our two factored forms, one side is x plus 3 and the other side is x plus 8. This could be x plus 8 and then x plus 3. It doesn't matter. It's the same exact thing. And our last one is that same 24 and that same x squared. This time, again, I need to add to get 25. If I follow my path, I already did the work, and I know that 1 times 24 gives me 25. So if I make my box, here's my 24. Here's my x squared, and I know my solutions are 1 and 24, because again, that adds to give 25, the middle term, which is what I want. So my two factors are x plus 1 and x plus 24. That's my factored form from this expanded form problem. We're going to keep on going, and that Elise person, that whole page is wrong, so just cross that off. So, in letter E, this simplifies into x squared plus 7x plus 10. So my 10 goes here, and my x squared goes here. I want two numbers that multiply to give 10 that add to give 7. I was actually already given the answer of 5 and 2. If you think about 10, it only has two factors, 10 and 1 and 5 and 2. And 5 plus 2 is 7. So 5 and 2 are my answers to get the 7. So I'm going to have 5x and 2x. So my factored form is x plus 5, x plus 2. You may want to pause again, try to do number 2, and come back and see if you did it right. This again is a 10. My only factors of 10 are 1 and 2, 1 and 10, or 5 and 2. 1 plus 10 gives me 11. So I know that 1 and 10 are my two factors that multiply to give me 10 and add to give 11. So this would be our 10x, and again, the green can be flipped. So our factored form is x plus 10, x plus 1. Alright, this time I have a negative 10. I need two numbers that multiply to give me negative 10 and add to give me positive 3. Well, to multiply to give me a negative, one has to be positive and one has to be negative. So I'm thinking of all of my factors where one's positive and one's negative. If I need to add to get a positive, then the bigger number has to be positive. So these two could not work. This one would add to give negative 9. This one would add to give negative 3. So my one that adds to give 3 is 5 and negative 2. And that's just my answer. X plus 5, x minus 2. If you want to look at that in the box, we have a 5 and a negative 2. And you can fill everything in. All right, two numbers that multiply to give 15 and add to give 16. That would be 15 and 1, 5 and 3, and that's my only two factors. So 15 and 1 adds to give 16. So I have x plus 15, x plus 1. If you're feeling confident, it's not mandatory to draw this box, but the beauty of the box is just so tough to resist. Alright, this one's a little weird because we have something that multiplies to give a positive and adds to give a negative. So it has to be a negative times a negative, because that would add to give a negative but multiply to give a positive. So which of these add to give negative 8? And then that's your factored form. When you're drawing the negatives, I would not worry about shading whatsoever. I know that was a little confusing yesterday. If you just label it as a negative, that says that you're adding a negative. So we've got a negative 3 and a negative 5. That'd be a negative 3x and a negative 5x. And that checks out to that. Two numbers that multiply to give 36 and add to give negative 12. So 36, we've got 1 and 36, 2 and 18, 3 times negative 12, 4 times 9, both negative, and we have our answer, so we don't even need to go any farther because that adds to give negative 12. So again, our two factors are x minus 4 and x minus 9. It is totally acceptable to have the 9 first and the 4 second. It does not matter because multiplication is commutative.